as I said, there are two methods that are available. One is Rayleigh's method. In Rayleigh's method, the disadvantage is that you can solve only till how many parameters? Only 5 or maybe 6, or no, 6 is not possible. Till 5 you can solve, but till 5 itself it will become very difficult in Rayleigh's method. So that is why we are going for pi theorem method. So okay, in Buckingham's pi theorem method, this is a statement. So if there are n variables, okay, look at this statement I have shown you in red. If there are n variables, independent dependent variables in a physical phenomenon, and these variables contain m fundamental dimensions. Okay, what are the fundamental dimensions? M, L, and T, and the variables are arranged into n minus m dimensionless terms. So this is the, and each term that they get from these is called as a pi term. Okay, this is what is Buckingham's pi theorem is. So there will be, let's say there are 7 parameters given in the question. So everything, all those parameters combined together, it will be called as n. Okay, n is equal to 7. Okay, in that we'll be choosing in which and all fundamental dimensions are available. So if all these 3 fundamental dimensions are available, then I'll take the m value as 3. All are available. If only L are there, or if only L and T are there, or we have just M and T are there, means then your value will be only 2. Or if just one of this is there, it means it is 1. Okay, then the next thing that you'll be doing is n minus m. In that one you'll get what you'll get. Let's say this is 3. Okay, let's say this is 3, so it will be 7 minus 3, which will be 4. Okay, it will be 4. So n minus m. So it means that you're going to solve for 4 pi terms. Okay, you're going to solve for 4 pi terms. Clear? Okay, this is what the statement is. Next. So as I said, these are the selection. How do you select a repeating variable? The first, these 5 points are very important. Okay, this what is the first thing that it says? That the dependent variable should not be selected. Okay, dependent variable, because that is what you're going to find out. Okay, that should not be selected as a repeating variable. That is the first condition. Second condition is the repeating variable should be chosen in a way that one variable contains geometric property, then flow property, and fluid property. I told you GFF, which means good friend forever. Remember this particular term. G stands for geometric, flow, and fluid. Okay, that's what is explained here. So examples of geometric property are length, diameter, and height, velocity and acceleration for flow property, and for fluid property it is viscosity, density, and angular velocity. Flow property will come into play only when the fluid is flowing. Okay, if it is not flowing, this velocity and acceleration, it cannot happen at all. Correct? Velocity and acceleration will not be there when the fluid is not flowing. Clear? So what happens is mu and density, all those things, okay, it will be there even when the fluid is not flowing. So that's why it's called as a fluid property. When the fluid is stationary or when it is moving, under both conditions these 3 will exist. Okay, that is why it's called as fluid property. Then some other conditions are also there. One is repeating variables should not form a dimensionless group. So finally it should not come into 1 or 0 or something like that. It should have some dimensions in the end. Okay, that's what third term means. Fourth term is repeating variable together must have the same number of fundamental dimensions. It should have same number of fundamental dimensions, and no 2 repeating variables should have the same dimensions. It should not be like L comma L. The final value should not be like that. Okay, these things also not there. Then some common repeating variables are dv rho, lv rho, lv mu, and dv mu. These are some 99%. This is how the repeating variables will be there. That 1% is where you have to choose. Okay, so let's look at a sum, and these are the steps that we'll be following. The first step is forming the equation. Question, I'm going to form the equation. Clear? Based on the parameters that is given in the question, I'm going to form the equation. Step 2 is I'm going to substitute the dimensions or the number of fundamental dimensions. Okay, that is going to be put in the step 2. And then I'm going to find out the number of fundamental dimensions available. That is the m value I'm going to find out. Okay, number of pi terms. I'm going to find out. That is just n minus m. Then choosing the repeating variable. That is the important part in Buckingham's pi theorem method. Okay, if you choose the repeating variables wrongly, what will happen? Your whole sum will collapse, or the equations will become messy. Okay, it will not be in the correct form. So this choosing of repeating variable should be done carefully, very you should be when you do this. Then step 5 will be writing the pi terms. Okay, after choosing the repeating variables, you have to write the pi terms, then solving the pi terms individually one by one. Now let's say pi 1 is there, you have to solve it, then pi 2, pi 3, pi 4, like that. You have to solve each one separately. Then take all the pi terms, put it back in the first equation, okay, and then form the expression. Okay, that is the final output. So these are the steps that we'll be following. Clear? So first was forming the equation. Step 2 is substituting the dimensions, and then the number of fundamental dimensions you're going to find out. Then step 3 is number of pi terms. Step 4 is choosing the repeating variables. Step 5 is writing the pi terms. Step 6 is solving the pi terms one by one or individually. Then step 7 is substituting back the pi terms and form the expression. Okay, so this is a question. Look at it. Clear? Derive on the basis of dimensional analysis suitable parameters to present the thrust developed by a propeller. Okay, thrust developed. So we can take as force itself. So P is equal to, now what does it depend on? You see, function of, I'm going to put everything else in the bracket. Okay, all these things, the thrust depends on these factors. So thrust P depends upon the angular velocity omega. That's going to be my first term. Clear? Then speed of advance, which is velocity speed V, diameter D, dynamic viscosity mu. Okay, then mass density rho, elasticity of the fluid medium, which can be denoted by the speed of sound in the medium C. Okay, any other 1, 2, 3, 4, 5, 6 other. Now what I'm going to do, I'm going to take function 1. Okay, and I'm going to put everything inside this now. Okay, function 1, I'm going to include the thrust also. P omega V D mu rho comma C. So how many terms? Can you count it out? 1,
7, sir.
2, 3, 4, 5, 6, 7. Okay, so there are 7. So your n value is going to be 7 now. Okay, these are the number of variables or number of parameters. Okay, that's what I have written here. Okay, so P is equal to f of omega V. This is the first step that you have to do, forming the equation. Step 1, f of omega comma V comma D comma mu comma rho comma C. Then f1 of, I'm going to take the P value inside this place, okay, and put it as the first parameter. And if I count it out, I'm getting 7 parameters. Clear? Now I have that counted out and I put it as n is equal to 7. So this is my first step. First step is over. Next, step 2. We're going for step 2. Substitute the dimensions and find m. Substitute the dimensions and find m. I'm going to find out the dimensions of each and every parameter that is being mentioned here, and I'm going to write it. If you don't know these parameters, you have to derive it. Okay, you should know the formula. Force P, what did I tell you? Thrust is actually a force. So force is equal to mass into acceleration, correct? Mass into acceleration. Mass is, I'm going to take it as m. Acceleration will be what? Meter per second square. Okay, if it is meter per second square, I can write it as L by t square. So what will it become? M L. If I take the t up, t power minus 2. That's what it is. Okay, that's what it is here. Can you get it? So for that, just like that, you have to do it for all. Okay, omega, how did I get omega? Omega is equal to radians per second. Okay, radians is the formula, radians per second. Radians, let's take the radian as 1. So 1 by second, that will be equal to, 1 by second, that will be equal to 1 by t, that will be equal to t power minus 1. T power, that's what is written here. Velocity, it is what? V is equal to meter per second So meter is L per second, it will be T, so L T power minus 1. Okay, diameter is in meters, so L already mu, it's a big term. I've already told you how we are going to get mu. Okay, so it's always good to remember mu value, or else you have to solve one big equation and get this particular value. Yeah, so ml per minus 1 T power minus 1. Rho I can tell easily. Rho is what? Mass by volume. So kg per meter cube is the unit. Kg is in mass, meter cube is in L power 3, which is m L power minus 3. That's what I've written here. Okay, C is what? It's actually velocity again. Okay, again, this is where this velocity is v, this velocity is speed of sound. Okay, that is also meter per second, so it will be LT power minus 1. Now what we're going to do is, I'm going to check, is there any m over here in any of the equations? In any of these equations, if there's any place where there is just m, okay, I can take my small m value as 1. Okay, is there m anywhere? Is there?
Yeah.
Here it is, here it is, here it is. So I'm going to take my small m value as 1 for now. Then is there anywhere 2? Sorry, L? Is there anywhere
Oh,
L?
yes, sir.
Yes, it is there. So I'm going to take my m value as 1 plus 1. Okay, is there anywhere T? Yes, it is there.
Yes, sir.
So another
So
one.
M is equal to 3.
Yeah, so m is equal to 3. Okay, so this is my important step. Clear? So m is equal to 3. Next, what I'm going to do, I'm going to go for step 3. Step 3 is n minus m. N minus m. What is n? We have just figured out n is equal to 7. So 7 minus this 3. Okay, 7 minus 3 will give me 4 pi terms. 4, so that is 4. So I'm going to get 4 pi terms. So this is the function that I'm going to use later after finding out the pi terms. So f1 of pi 1 comma pi 2 comma pi 3 comma pi 4 is equal to 0. Clear? Now choosing the repeating variables, the most important thing in Buckingham's pi theorem. If you make mistake in this one, the whole thing will, it'll collapse, I said. Okay, it will become wrong. Okay, so you have to choose it wisely. Okay, now let's look at the equations. I have to choose GFF. Okay, what is the first property? What does G stand for? First G stand for geometric property. What is second one? Flow property. Third one is fluid property. Don't mismatch this. Okay, both are F, so don't mismatch.
Yes, sir.
Okay, you should not mix both. Okay, if you interchange this, then that will also become wrong. First is geometric property. Next one is flow property.
Flow.
Next one is fluid. Fluid comes in the end. Okay, if you put fluid in the second place, means it'll totally become wrong. Okay, so be careful when you put it. Now, is there any geometric property here? There is only one geometric. Geometric property means what? Something which is related to its size. Okay, size in the sense diameter. So this is your geometric property. Clear? So I'm taking the first one as D. Then velocity, that is flow property. Velocity is there, angular velocity is there, sound is there. All these are flow properties. Okay, but I cannot choose angular velocity over velocity. Velocity is the first thing that's given preference. Okay, first it is velocity and then only angular velocity. So the first preference goes for velocity. Sound and all comes next only. Okay, clear? So velocity is the first preference, so I'm going to give velocity my flow property status. You're giving status. Okay, now next is fluid property. As I said, fluid property, the preference are rho then mu. Okay, there is rho, there is mu. Clear? But I should give preference for what? Which one? I should give preference for rho. So I've given the fluid property status to rho. Okay, now I have declared the status of all these repeating variables. Now what I'm going to do, I'm going to write 4 pi terms now. Pi 1, pi 2, pi 3, pi 4. These 3 terms I'm going to write it as d dot v dot v rho. Okay, d dot v dot rho, d dot v dot rho, like that 4 times I'm going to write it. Okay, then on top I'm going to write a1, b1, c1, Similarly, if it is second item, A2, B2, C2, A3, B3, C3. Similarly, A4, B4, C4. Now I've written it. Clear? Next, I've written the repeating variables 4 times now. Now, how do I write the fourth term? Very simple. Go back to this equation, step 2. Okay, strike off what and all you have given as repeating variables. D I have given, V I have given, then row I have given. All the status, it deserved the status of repeating variables, so I have given those status. Now what is left out? P is left out. Take P and put it in the first term. Clear? First one is over. Then what is left out? Omega, put it in the second pi term. Okay, as the fourth term. Then mu, I'm going to put it in the third one. Then comes sound, velocity of sound, I'm putting it in the third one. So my step 5 is over. Be sure that you have to write this order with respect to the question. This question, whatever order that is followed, the same order I've written here. That is why I'm able to get these things correctly. Clear? If you leave the order and if you mix the order, means what will happen? The question, the expression that you are getting will become, again, it will mix up. So follow the same order that is given in the question. What is the question order? First is P, force, then angular velocity, angular velocity, and then speed, diameter, viscosity, mass density, and then speed of sound. So same order I have followed. Now I'm going to solve the step 6 is solving each pi term. First of pi term I'm going to take dv rho p. Okay, this first pi term I'm going to take. I'm just going to write it as pi1 is equal to d power a1, v power b1, rho power c1, and p. Clear? Next, substitute the dimensions. That's my integral step. Okay, this is the internal step that we are going to follow. Okay, for pi1 it's going to be always m power 0, l power 0, t power 0, which all it will come to 1, because anything power a power 0 is 1. Okay, so 1 into b power 0, c power 0, if you put, everything will become 1. So that's what the pi term means. Clear? Now for d, what is the dimension? We have already written all the dimensions here. You can, if you have written all these things correctly, or if you have it in memory, you can always write it directly over here. Okay, so l power a1, then for v it is lt power minus 1, for rho it is ml power minus 3, and for p force it is ml t power minus 2. So I have substituted all the dimensions. Now I'm going to equate the powers. Power of m I'm going to take. Okay, power of m. Okay, now what I'm going to do, power of m on the left hand side, m, what is the power of m? It is 0, so I have put 0 here. Now you look at the right, there is here, there's no m here, but there is an m here. What is the power of m here? 1. Okay, 1 into c1. Okay, what will that will become? C1. 1 into c1 will become c1. Then there's another m here. What is the power of that? 1. So I'm going to take c1 plus 1. c1 plus 1. It's like this: a power m dot a power n is equal to a power m plus n. That's how the algebraic thing works out. Okay, so c1 plus 1. From this I can tell that c1 is equal to minus 1. This step we will do it in the end. Okay, next, power of l. Power of l will be, on the left hand side it is 0, on the right hand side it is, there's a power of l here, a1. I've written a1. Then over here there is 1l. Okay, for this the power is 1. The power of that is b1. So 1 into b1 will give you b1. Okay, so plus b1. Look at it, this one minus 3, it is c1, become minus 3 c1. I have put it here, minus 3 c1. Then over here there is only 1. The power of l is 1, so I'm putting it as plus 1. Okay, so I'm just going to keep this as, this step will do it in the end. Going for power of t. If I go for power of t is, on the left hand side it is 0, and on the right hand side it is minus b1, because 1 minus 1 into b1 will be minus b1. and then power of this one will be minus 3c1. Sorry, we are going for t, right? Leave this. Going for t, it is just minus 2. So minus b1 minus 2 will give me b1 is equal to minus 2. c1 is equal to minus. I'm just simplifying it. Okay, simplifying this equation, clear? Now in the end, a1, if I have to find out a1, take a1, keep a1 on one side and take all the things to the other side. Clear? If I take all the things to the other side, I'll get one equation. Then in that, look at it, minus b1 plus 3c1 minus c1. In this, I'm going to substitute b1 as minus 2 because I have found out b1 and c1 here. b1 and c1, I'm just going to substitute it here, and c1 I'm going to substitute here. If I substitute it and simplify it, it will become minus 2. Now let me powers and put it back in my first equation. Look at it. This is a1 will come here, that is minus, so it will be d power minus 2, v power, what is b1 value, again minus 2, rho power c1 will be minus 1 into p it will be. Okay, that's what I've written here, d power minus 2, v power minus 2, rho power minus 1 into p. Minus 1 whole power minus 1 or minus 2 means it has to go to the denominator, so I'm going to take all the minus terms to the denominator. So only thing that will be in the numerator is p divided by d square v square rho. So this is my first pi term. Clear? Then I have to do it for pi 2 as well. Similarly, pi 3, pi 4. Okay, we'll just look at pi 2 now. dv rho omega is my second pi term, dv rho omega. So when I substitute all the dimensions, I'll get this equation. Then I'm going to equate the powers. Equating the powers, left hand side m is equal to 0, right hand side there is only c2. Okay, so that will become c2 is equal to 0. To go for L left hand side 0, right hand side will be a2. Here a2 plus b2 minus 3c2, a2 plus b2 minus 3c2. Then for t power of t, it will be left hand side 0, right hand side it will be minus b2 and then minus 1, minus b2 minus 1. So c2 will be 0, b2 will be minus 1. If I substitute b2 and c2 value in a2, I'll get a2 as 1. So let me substitute back the powers, 1 minus 1 and 0. Substitute it, rho power 0 will become 1. Okay, this will become 1. So my leftover equation will be d omega by b. Clear? D omega by v. This is d, it will be the numerator. Since v has minus 1, it has to go to the denominator. Then this has become 1 because anything power 0 is 1. Yeah. Then omega, it stays in the numerator. Similarly, we're going to solve pi 3. Okay, you can just have a look at pi 3. How I have solved it. Same step, everything is same. Power of m, power of l, power of t, and I'm getting m value as minus 1, b3 value as minus 1, a3 value as minus 1. All are minus 1. I'm substituting back the powers, then I'm forming the equation. Pi 3 term I have got it mu by dv rho. Similarly, pi 4. Substituting the equation, then power of m is 0, power of l is 0, sorry, power of t is minus 1. If I substitute c4 and b4 in L, I'm getting a4 as 0. a4 I'll get it as 0. So if I substitute back all the powers in the equation, I'll get my final term as c by v. Okay, you can just have a look at it. Now what I'm going to do, I'm going to take 7 pi terms and put together. I'm going to take all the pi terms that I've just found out. Whatever pi terms I've just found out, I'm just circling it. Pi 1, pi 2, pi 3, and pi 4. Okay, so I'm going to put all this into one f1 equations all equal to 0. Then I'm going to take the first pi term and I'm going to put it on the left hand side. I'm putting it on the left. Why? Because this is what I'm going to find out. This is what I have to find out. P, that is a thrust force. P doesn't mean it is pressure here. P is your thrust force. Clear? Just because I have taken it on the left, I'm introducing this constant, which is phi. Clear? Now what happens? This bottom denominator, I'm going to bring it to this right hand side numerator. Okay, so this has come here. So P is equal to d square v square rho. Then comes the constant. Why is this constant? Because there might be a lot of numbers involved here, because I have just taken this particular thing to the from left hand side to right hand side. So some numbers or some constants will be involved. That constant to all together, I'm putting it as phi. And d square v square rho will come to the right hand side, and then the remaining everything stays the same. Okay, d omega by rho, mu by d v rho, and then c by v. So this is how we form the final equation. We had how many terms? 7 parameters here, and we were able to solve the pi terms and get one final expression for this particular problem. Clear? So this is how we solve the Buckingham's pi theorem method. Clear? So thank you all for joining. See you next time.